In one of my previous roles, a professor in computer science came up to me and issued me with a directive to buy me one of those HPC laptops. I guess if a dean of computer science doesn't understand the concept of HPC, then it's worth making a point of it. When designing an HPC system, it's not like picking one out of a catalog. Designing an HPC system requires some fundamental considerations. First, and perhaps obviously, it's important to know what you intend to do with your system. For example, who are the primary users? Will there be astrophysicists, bioinformaticians, Bitcoin miners, and so on? What do we want to do with the system? For example, will we be focusing on drug discovery, weather forecasting, or playing crisis? Hand in hand with this, you need to answer the previous questions in line with what you can actually physically do with the proposed system. Do we have power limitations? Do we have cooling constraints? Do we have a physical room limit? Do we have a floor capacity weight limit? Is there a noise concern? And probably most importantly, do we have a budget limit? Then, once you have established the basic underlying purpose and constraints, you need to consider hardware options and software options. And I'll throw this in there. A very important and often underrated component is actually tapping into the HPC community for their expertise. There are many people that have done what you're trying to do already. And the biggest problem that I have experienced in my line of work is that so many newcomers are trying to build an HPC on their own, and they often have little or no advice from anyone that's worth asking. And why does that matter? With a typically very expensive investment, and I mean we're talking from as little as a couple of R100,000 to perhaps several million rand, it's not something that you really want to mess up. There are various software components in an HPC system. The primary software subsystems will be an operating system, and this is almost certainly going to be Linux, and software tools, both for administering the cluster and servicing the user needs. While Linux is almost certainly the operating system, the tools installed in the HPC cluster can be either commercial packages or free and open source options. And we'll leave it at that for now. We will go into much more depth about software in the chapter that covers the software stack. And for some of you, Linux might be a new operating system to deal with, and you might feel more comfortable running an operating system that you're familiar with, like Windows, Mac OS. So why Linux? There was once a time that Linux was not the only option for an HPC system, but as it currently stands, if you take a look at the top 500 by operating system family, Linux runs 500, or according to this, more than 500, of the top 500 HPC systems in the world. So based on that, it's probably a good idea to stick with Linux. And within that Linux family, almost 1/4 are running CentOS. And that is the OS that you'll be working with in this program. The typical pieces of hardware that you need to contemplate for an HPC system include something to manage the HPC system, such as a management node, something to do the actual work, such as a compute node, something to store the data, such as a storage system, something to allow communication across the HPC system or the cluster, and that would be your network or interconnect, and accelerators if appropriate. Now, very briefly, an accelerator is essentially just a dedicated piece of hardware that's designed to perform extremely well for a very specific type of task. Let's take a quick look at the HPC subsystems as I've broken them down in this infographic. The bold items in this infographic are hardware components, but I'll be more explicit about making those obvious to you as we go through the list. You will have one or more operating systems in your HPC system, and the reason that we can actually have more than one operating system is because the management infrastructure might differ to the compute nodes or to each other. There will need to be something to manage the network, as well as an actual network interconnect. The interconnect is the physical component here. In particular, the management server will also run various services, such as DHCP, monitoring, DNS, a scheduler, and so on, and we will talk about those again in the chapter on the software stack. The system might also offer various HPC software packages. You might have some nodes that use accelerators, and these are a hardware component. There'll need to be a storage subsystem, and that will require both a physical hardware as well as a specialized configuration of that hardware. Often overlooked, but of immense importance, is that every HPC system needs some cooling and some power. And although not an explicit component of hardware for the HPC system, you can consider it to be infrastructure hardware. Finally, you may also want some form of redundancy, that is a backup power system, backup storage, backup network, and so forth. When it comes to the network, you need to consider the physical medium, such as whether it's going to be InfiniBand or Ethernet. And while InfiniBand has better performance through high throughput and low latency, budget constraints might actually dictate an Ethernet infrastructure because it's cheaper. And once you've decided on your chosen medium, it might dictate or actually be dictated by the topology of your network. That is, the layout and the desired behavior that you want to achieve with your network. And we'll wrap up this morsel with another fun tidbit. Remember TAC, the Texas Advanced Computing Center in Austin, Texas? Their Ranger HPC system was such a big and interconnected HPC system that it ran 16 kilometers of network cable. It had 2 Magnum switches, one of them pictured here, and each one of those switches had a whopping 3,456 network ports. Your traditional network switch on, say, a fiber router would have 4 ports.